right, so the laws that we're going to talk about are called the Newton's laws of motion. And there are three laws that Newton's laws of motion. And there are three of them: law number 1, law number 2, law number 3. And we're going to talk about them one by one. Law number 1, or Newton's first law of motion. It has another name. It's called inertia, or inertia. It's a definition, it's a law that states that any object at rest means no velocity, velocity equal to 0. Objects at rest is, for example, with respect to your point of view, your phone on your desk is at rest with no velocity. So any object at rest will stay at rest, and any object in motion will continue its motion with a constant velocity unless there is an external force, and if objects are at rest or objects are moving with a constant velocity, we can conclude that the combination of all external forces are equal to 0. So the equation coming from this law says that the combination of forces, considering all the forces acting on an object, if that object is not moving, or if it's moving with a constant velocity, in both cases, the combination of the forces is equal to 0. Okay? So I give a quick example. If you are looking at a box that is sitting on the floor, and it's not moving, so therefore the forces, therefore there's no acceleration, and therefore this object is at velocity equal to 0. It's at rest. So Newton's first law of motion, or inertia, applies in this case. It says there are either no forces acting on this object, or if there are any forces, the combination of all forces must cancel each other out, and the resultant force must equal to 0. It means that if we have a force of gravity, we must have another force acting the other way, which is happen to be the normal force, and the combination must still cancel each other out to give you the 0. If that happens, the object is at rest, and first law of motion, or Newton's first law of motion, or inertia, applies. Okay?
Yeah.
One more quick example.
What's inertia again?
Inertia is another name for Newton's first law of motion.
Okay.
So law of inertia is another name of Newton's first law of motion. Inertia is the concept of the idea that any object with at rest, which means the velocity is 0, or any object that is moving with a constant velocity, the forces acting on that object must result in 0 and must cancel each other out. So I'm going to give you one more example. Another example could be, again, another object on the floor, and at this time you're putting and applying a force to this box of 20 Newton. Let's say yourself is pulling, you're pulling this box towards the right side, and the box is not moving. Okay, so the box is very heavy and it's not moving. Okay, so since it's not moving, the velocity is still equal to 0, even though there's a force, but the velocity is still 0 because the box is not moving. Since the box is not moving and the velocity is 0, then we are considering the Newton's first law of motion, or inertia, which says the combination of all forces have to be equal to 0. So the question is, if we have a force of 20 newtons towards right side, we must have another force. There must be another force this way with the same amount of force to cancel the 20 Newton out. Otherwise, if there was no other force on the left side, this object must start to move. Now, what is this force? We all know that there is a force of friction. And if that force of friction is strong enough to be 20 newtons, it can actually fight back against your force and keep the object from moving. Does that make sense to you?
Yeah.
So this law also includes the situation that if an object is moving with constant velocity. So now in that case, we have to imagine a situation. Let's say we have an object moving in space, okay?
Okay.
Far from Earth. Let's say there is a piece of like a rock or piece of rock moving in space with a constant velocity, okay? Constant velocity, let's give it a velocity of 100 meters per second. It's moving very fast into certain direction. The direction is unknown, but it's moving away from Earth. Now, we know that the velocity is constant. Velocity constant means there is no acceleration, correct? We learned that in the previous chapter. Then when we say the velocity is constant, object is moving with the constant velocity, it means the acceleration is equal to 0. If that happens, again, that falls under the category of Newton's first law of motion or inertia, which states again, if object is not moving or if the object is moving with the constant velocity, in both cases, we can conclude that the combination and resultant force acting on that object must be equal to 0. So this means if there are any forces, which they are, acting on this piece of rock, example is the force of gravity from other planets. So if this object is moving in space, there's going to be other planets that are basically their gravitational force is acting on that object and pulling it towards themselves. One of them could be Earth, one of them could be, I don't know, Mars or the Moon or Jupiter or other planets. They're all acting on this object. But if, as a result of all these forces, the object managed or has the motion of constant velocity of v equal to 100 meters per second, we can conclude that the submission of all the forces, the resultant force of all of them acting on this object must be equal to 0. So whatever this number is, maybe it's like this: 30 newtons to the right, 30 newtons to the left, and then maybe there is some forces acting this way, and whichever amount these forces are, when you're considering it as a combination of all, they all cancel each other out, and this object experienced the condition of inertia, which means all the forces acting on this object cancel each other out, and it stays and continue moving with a constant velocity of 100 meters per second.
Okay.
This is Newton's first law of motion. Now, Newton's second law of motion speaks about the other condition, the other type of movement, where we can call it Newton's second law. There's no other name. So Newton's second law of motion says that, okay, so Newton's first law talks about objects that are not moving or moving with a constant velocity. How about the objects that are moving with acceleration? Most of the objects we see in our life, in space, on Earth, and most of them are moving with acceleration. All the cars, all the objects falling from the sky, moving animal, moving objects, most of them are with some sort of an acceleration. So what kind of law and what kind of regulation and rule applies in that case is that we have the Newton's second law of motion equation, which states that if you have an object that is moving with an acceleration, and there are a lot of examples of it. If that's the case, the combination of the forces acting on that object is not going to be equal to 0 anymore. It's going to be equal to the mass of the object multiplied by the acceleration of the object.
Okay.
So this is the equation we use when we have the condition for Newton's second law of motion. So in other words, when we're looking at a situation and we were looking to analyze and break down the forces and analyze the situation, maybe we're looking for acceleration, maybe we're looking for friction force, but we need to analyze the situation. First of all, we have to decide, are we working with a case in Newton's first law of motion, or are we working with a case in Newton's second law of motion? Because they have two different equations. One of them, a combination of force is equal to 0. The other one, combination of force is equal to m times acceleration. So first we have to make a decision which one it is. And there's only like one test and one way to find out. If the object is moving with no velocity, in other words, the object is at rest, or if the object is moving with the constant velocity. This is very important. So there are two types. Either no velocity, which means the object is not moving at rest, or even if it's moving with a constant velocity, that falls under Newton's first law of motion. Okay? So as soon as you read the question and you see that the object is at rest, or if the object is with a constant velocity, right away we say that this is the case with Newton's first law of motion. And on the other case, when you hear object is moving with an acceleration, just like the recent example what we did together, in that case, right away you can conclude that the situation is considering in Newton's second law of motion. So when you hear things about moving with acceleration, so acceleration could be positive, could be negative, but in both cases it's considered to be an acceleration. So in any case that we have an acceleration in our movement, then we right away say that this is the second law of motion, and we need to consider that category. So this is a decision we have to make right in the beginning of our like solving and tackling our question. Now, the third law of motion is quite, it's a little bit different compared to first law and second law. So first law and second law are the two categories of motion, one with the constant velocity or no velocity, the other one with acceleration. But third law of motion, third law, Newton's law of motion, talks about completely something different. It's a property of matter, I would say, that it states that any force that we ever talk about and we ever compare in physics always comes as a pair. There's no force that exists as singular. Any force always has a reaction force. Any action has a reaction force. So if we talk about Newton's third law of motion, that it says there is always an equal magnitude and opposite direction force acting on any force being applied on objects or a person. A best example for it is that let's say, I mean, the most convenient example that we might have all experienced is if you hit the wall with your hand or hit an object with your hand and apply in force. Let's say you punch the wall with certain amount of force, 10 newtons, 15 newtons, then it appears or it feels to you that the wall is also applying a force on your hand because you start to feel like your hand hurts. Basically, the wall is hurting your hand back. So that's the best way of describing Newton's third law of motion, which says any force that ever gets created as a result of any type of energy being spent always exists as a pair of force that are exactly same magnitude, opposite direction. So it means that not only when you apply a force of 20 newtons into a wall, not only you experience a force backwards against yourself, but that force against you is exactly equal to 20 newton as well. So the harder you punch the wall, the harder the wall will apply a force back on you.
Mm-hmm.
And that applies in every force that ever is considered in science and physics.
Is
So
it
we'll
not?
talk about that later on as well. That any force every time it comes as a pair, opposite direction, and the same magnitude. Go ahead.
Mm-hmm. Is it the same like force applied back? Like, isn't it like if let's say you hit it with 15 newtons, it wouldn't be 15 newtons back?
Yeah, if you hit with 15 newtons, it would be 15 newtons back.
Okay.
Yeah. So and then when you increase it, you punch it harder. You also feel it harder as well. So scientifically speaking, when you are applying force on the wall should be the only object receiving the force. You should not receive any force because you're applying the force. But because of Newton's third law of motion, and because every action has a reaction force, same magnitude, exactly opposite direction, at the same time that you're applying a force on the wall starts to apply force on you as well,
Okay.
based on Newton's third law of motion. So it's a little bit different law compared to first one and second one, but it's it needs to be considered, especially in some cases that we're going to talk about in examples later on. So Newton's third law of motion. It says that for every force, there's an equal magnitude, opposite direction pair of force acting on the object. So for every force, there is an equal, this is very important, it's exactly equal and exactly opposite direction. Acting back. So that is also being considered in a lot of cases. We're going to look at in future examples. Just to kind of have a summary of all three laws. I'm going to briefly go through all of them. So first law and second law of motion, they are very similar to each other in terms of showing two different categories and two different types of motions. One being inertia, following the state of inertia, or following the first law of motion, which says the object is at rest, just like most of the objects that you see at the room, your desk, your table, yourself sitting, objects on the tables, they're all in inertia state and falling in the category of the first law of motion. Even when the object is moving with the velocity of constant velocity, so that could be in a lot of cases, let's say someone ice skater on ice moving with a constant velocity, so that if that person manages to move in a certain distance with a constant velocity, that just means that falls under the category of Newton's first law of motion and law of inertia, which states that the combination of forces acting on that object must cancel each other out and they all become equal to zero. Okay, so that is what we concluded with the writing of sigma f equals to 0. Now, another type of movement was when object is moving with an acceleration. For example, airplane moving in the air with an acceleration, or car moving with an acceleration, or you running with an acceleration. All those motions do not fall under the first category or law of inertia. They're this Newton's second law of motion, which says that if an object is moving with an acceleration, the combination of all the forces acting on that object must be equal to the mass of the object times the acceleration. Now, when we're working with numbers and examples, this concept would be more clarified. But as of now, we have the first law and second law taking care of different types, two categories of motion. Newton's third law of motion, the third law is quite different approach to looking at forces. It just mentions and kind of like reminds us that every force that we ever talk about, we need to always consider that every force comes with a reaction force, equal magnitude and opposite direction. We may consider those forces, we may calculate them in some examples and questions. We may not, sometimes we ignore them, like it's not part of the question or it's not being asked. But if it's being considered, based on Newton's third law of motion, every force has a reaction force, and so the most convenient example is someone punching a wall and the wall punching the person back. If you actually hit it really really hard, you may feel the punch back strong enough that makes you like fall down, or you feel the push stronger that pushes you back. Now, and a little bit more complicated or complex example would be the force of gravity. For instance, the gravitational force between Earth and Moon, two objects in space. Earth is attracting or um, having a pulling force uh, towards Moon and keeping it in a circle around Earth. At the same time, Moon is applying the same amount of force back to Earth. So even the gravitational force also follows Newton's third law of motion, which states again, any force on exists in the universe, which we talk about and we want to consider, they always come as pair. And a force and always have an equal force acting opposite direction to the first one, equal magnitude and exactly opposite direction. So these are the three laws of motion, which they describe all conditions of movements and motion on um, in mechanics. So it covers most of the types of the movements, either moving with no velocity or constant velocity or moving with acceleration. Now we can analyze and we can work with these equations, as well as always considering the Newton's third law of motion. Okay?
Mm-hmm.